kapasitasnya adalah 20 meter kubik per jam. Kemudian karena dia di ujung juga kita menggunakan 18 meter, dan kemudian kita ganti juga selangnya di sini. Jadi di ujung di sini tadi seperti di situ itu kita ganti menjadi 20, kemudian ini 18, kemudian 1,6 itu adalah gaya geseknya. Kemudian 2 meter ini apa? Karena satu section ini, satu pipa section ini diambil sampai 2 meter dan elevasinya, dan kemudian kita dapatkan menjadi 21,6 meter.
Up to this point, and let's start the calculation. What do we have here at this point? So Q is now 40 cubic meter per hour, and P, what's the situation with P? We start with 21.6. We add the friction, it's a bit longer section because we're going down. Let's say friction will be now 2 meters. What happened with the elevation? From here to here is 1.5 meters. So 1.5, 1.5. We end up with 23.6, 25.9, 25.9, almost 26 meters. So I got this 19.7 here, and I got this 25.9 or 26. I'll round it up to 26. Among these two, when I'm continuing now with the bigger pipe, much bigger pipe, I need to consider, of course, the highest one. Okay? So now I'm going to use the bigger pipe all the way down to the pumping station.
Nah, jadi oleh sebab itu kita dapatkan berapa tekanan air yang dibutuhkan di center atau di tengah-tengah lahan kita. Kenapa kita menggunakan yang 25 karena harus menggunakan tekanan yang paling besar. Nah, kalau yang dari ke arah area sebelah sini itu dia ternyata 9,7, kalau yang area sebelah sini adalah 25,9. Oleh sebab itu pipa harus disesuaikan dengan yang 25,9 area paling besar. Jadi pipa bakal disesuaikan di 25,9 menuju ke pusat pemompaan air.
Let's find out what's my situation here. So Q is 80 cubic meter per hour, because it's 40 here and 40 here. Yes. 80 cubic meter per hour. P. I start with 25.9. Do you allow me to round it to 26? So it will be here.
Kita bulatkan aja yang ke 26.
26 meter. Here we are 110. So elevation is 10. What do you calculate now here? So now I need to calculate that one.
Jadi kenapa ini ada 80 meter kubik per jam? Karena ada total berapa?
You remember that we said that automatic filter we always do backwash after half a bar, 5 meter or 50 kPa. Then we need to consider also the filter. We're also going to add here for the filter another 5, and we're coming to 47, and that is going to be our duty point for the pump. 47 meter, and again you can round up to 50, and that is what we usually do.
5 meter
For the filter.
Tekanan air juga, dan kita tambahkan biasanya adalah 5 meter, biasanya itu 8 juga sampai pos. Jadi kita tambahkan 42
is how it's done. When you're doing manual design, this is how we do the manual design. Just go section by section. We see later on the system will do this.
Jadi kalau kita secara manual ini menghitungnya dari section ke section untuk mendapatkan angka berapa yang akan kita butuhkan.
And if you're doing a small farm for your own, you have now enough knowledge to do it by yourself. You're going to do it quite nicely. Okay. So that's what we say. If we find the point that we are losing too much, we just make it bigger diameter. Yes, that's the point that we are doing when we define diameter. Now, I want to introduce you, I said it already, the bigger design offices. I just want you to know how it goes, some information about it. Uses much more expensive software called Erika, we see the video. But first of all, the process starts with surveyors. You all see these people, they come with those instruments and they come up with the map. Computerized map.
Jadi biasanya untuk yang main di komputer biasanya itu dia adalah yang bisa bekerja itu.
The computerized map. Yeah, the computerized map uses a file format that's called DXF. And this is the product. When you call somebody to make a survey on your field, it will bring you the format, the file as DXF. When I load the DXF file on my computer, every point will have a coordinate. I'll show you in a minute, by the way. I have one on my computer. So, like, if I go with my mouse, I go like this, X will not change, X is this, but Y will change. Okay? If I go like this with the mouse, Y does not change, but X is changed. Okay? And if I go along the contour line, both X and Y changing, but also, Z, which is the elevation, for each point have three parameters. Latitude, longitude, and altitude. So the computer, when you load this file on the computer already has some information, some knowledge about how is the field built, how is your field, what is the length, what is the width, and what is the altitude.
Nah, jadi misalnya kalau kita pakai dari komputer, biasanya juga kita bisa untuk melihat berapa ketinggian atau elevasi dari field kita dari lahan kita, berapa altitude-nya, berapa panjangnya, kemudian berapa longitude.
Let me see if I have this file here. I can show you quickly.
Jam tayang.
Home.
Wala untuk subscribe sudah mulai.
Small place in the universe.
Pemain dari Borneo FC dengan pelatih mereka Joaquin.
Ya, tetap Borneo dengan
And if you look down here, you see the coordinates. X and Y. It's a little bit difficult to see, but you can see that when I move the mouse, all the numbers are changing.
Jadi kalau dipindahkan aja mouse-nya, pointernya, itu bakalan ada angka yang berbeda. Kalau dari sini semua ketinggian, latitude-nya,
Yeah, you can see whenever I move the mouse, all the numbers are changing. This is changing X but doesn't change Y. This is changing Y but almost doesn't change X. And altitude is not showing on this file, but on a proper file it's supposed to be shown.
jadi bakalan berubah semua altitude-nya apa semua kalau dipindahkan mouse-nya di setiap posisi dari rumah.
Okay, so you first of all load the map on the Erika. So Erika already know what does your field look like. Secondly, you mark all the boundaries of the irrigation drop. You make a new layer, you mark the boundary of the irrigation block. So this is the layer of the irrigation block. So that's what it looks like. And that's the second thing that you do. And now you select the equipment. You say, I want to use dripper 1 liter per hour every 20 centimeter or 30 centimeter. 2 lateral per bed, or whatever. You don't say the bed because the bed is not part of the design. You say what is the distance between lateral, and you press compute. The moment that you choose for every block what will be the equipment that you're going to use, you press compute, and the first thing you get from the software is whether you are okay or not okay with the flow variation. Flow variation not okay, you need to do some fixing, some improvement.
This is the block or the block space?
The red things are here are the blocks.
The right.
Yeah,
Next space or
say counters, pipeline, but if I do properties, I don't want to waste your time with that. Okay, that's just it's not very important. It's just for the impression. The likability that some of these students will ever work with this software is not very high. So.
Jadi dia bilang ini adalah bagaimana dari luas blok kita dan kemudian dari elevasinya nanti mereka juga sudah tahu. Jadi nanti kalau kita bilang berapa flow air yang bakalan kita kasih, nanti mereka bakalan bilang apakah itu bisa atau tidak, atau adakah yang harus diperbaiki.
And then the only thing that left is to lay the pipes on according to the criteria that we decide. 1.6, 1.7 meter per second. We decide the criteria. We let the software lay the pipe, or we lay the pipe ourselves. Laying the pipe from the field, from the block to the source of the water. Let's see the video.
The video.
Welcome to Irrigation Irrigation Design Software, your all-in-one design solution. Irrigation is an integrated software platform that allows you to complete design drawings, analyze complex hydraulic calculations, and effortlessly compile design and costing reports within a single platform. This integrated approach eliminates errors and simplifies your workflow. Irrigation can be used to design any pressurized system, including drip and sprinkler irrigation, parks and landscape irrigation, and frost protection systems. It can also be used to analyze and design extensions to existing systems, making design upgrades easy and keeping your information in one place for any future changes. It includes a comprehensive suite of CAD tools, customized for the easy input of pipes and components, along with graphical tools to aid in the placement of submains and mainlines.